Dear students, today we'll see transistor as an amplifier. It is a very important application of BJT. Okay. Now this is a circuit, and in this circuit the NPN transistor is used, and it is connected in a common emitter configuration that we have already told earlier. If you want to use transistor as an amplifier, you have to connect it in common emitter configuration. So emitter is made common to both input circuit and to the output circuit. So here the input is given between base and emitter, and output is taken across emitter and collector. Okay. Now here the first requirement of being to work as an amplifier, the transistor requires the first requirement as its emitter base junction should be forward biased and base collector junction should be reverse biased. That is the first thing what you have to produce. Those are the DC voltages. That is the type of biasing you have to do. That is the application of DC voltage what you have to give. And that will be given by VBB and VCC. So here if you see, the base should be forward biased. So base is, this is NPN, NPN. So this is PP is connected to positive. Okay, and N is connected to negative. So this junction is forward biased. Forward bias. That is the first requirement. Second requirement is base collector should be reverse biased. So collector is N, and this N is connected to a positive of a battery. Positive of a battery. So this is reverse biased. This is reverse biased. So the basic thing before applying the actual input, what you have to do is you have to give these DC voltages correctly. These are voltages for biasing. These are not your actual input. These are voltages of biasing. These are the ones which will make the field placing for the transistor to work as an amplifier. Now because of this biasing, we will see that whatever AC input we give, that AC input positive and negative half cycle will remain always on the positive side. Okay. Now here if you see, this is an AC input what you are giving. This is the input signal AC, whose amplitude is shown over here. This is how it is varying. This has been given here. Now that is been given as a base current to the base of the transistor. Okay. Now this voltage and this voltage are in series. So the DC voltage is in series. So this is a series voltage what you can see here. This is the series voltage. This voltage and this voltage is series voltage. Okay. Now whenever the input cycle goes positive, the collector current will increase more. Collector current will increase more, and that more increase will develop a voltage across RC V0. Okay, IC into RC V0, and that you can see here. So if this is your input, this is your input. So here the output will be like this. It is amplified. It is amplified. This is the output. So for this input, you are getting this output. Similarly, when the input goes negative half cycle, that is this, the output, the collector current will reduce. Okay, and the voltage across this will reduce, but it will reduce above the positive line only. So this is the reduction part, what you can see, but it is an amplified version. Okay, again when it goes positive, you can see a larger positive because a collector current passing through this RC, IC into RC will give you V0. Now what is happening here is you are applying the signal at a low resistance because the first junction is forward bias. The first junction is forward bias. It is low resistance. It is low resistance. Okay, so it is a low voltage which is going. Okay, once it is applied to this transistor, and when you get a collector current, okay, that collector current is being taken across a reverse bias junction which is high resistance. So your signal is passing from low resistance to high resistance. So once the current goes through a high resistance, it will produce a larger voltage. So a small signal will be produced big, a weak signal will be strengthened. This is called as amplification. This is called as amplification. So here you are transferring the signal from low resistance to the high resistance at the output. Low resistance at the input to the high resistance at the output. So this transfer of resistance gives the name transistor, and here transistor works as an amplifier because weak signal is made strong. A small signal is made large. Okay, and these two voltages will be in series because you have to see that the emitter base junction is forward biased and base collector junction is reverse biased. Okay, so these two will see that the variation of AC always remains on the positive side. It will not reverse bias the transistor.